So if we did a couple examples here, and I'm just going to erase my words here, but if we did a couple examples, everything is linear unless it has these things listed. So if I gave you something like y equals x plus 4, well, if I look over here at my list, as long as it doesn't have these things in it, that would be considered linear. So that one looks good. I've got an x and a y, and I'm good to go. There's no exponent or square root or something in the denominator, so this one is linear. Okay, what about if I have y equals 3x over 5? Well, again, it's still going to be linear. There's nothing that says anything about x being in the numerator. That's perfectly fine. So again, this one would be linear. If I gave you this one, y equals 2x squared. Well, that's automatically, I see a squared, and that's in the no-no list. So this one is going to end up being nonlinear. Still going to be a function, but it's going to not form a straight line. Something's going to curve in there. Alright, the last thing you're going to have to know about linear functions is that all linear functions are either discrete functions or what we call continuous functions. And again, it has to be a linear function in order to be considered this. So if it's nonlinear, then you wouldn't classify it as these two things. But if it's linear, then it's one or the other. So a discrete function means it has a discrete domain, which means that only certain values are going to make sense in the interval. And usually they're going to give you a graph. And when they give you a graph, if you see something like, let's get the graph paper here. If you see something that looks like this, and you're given this dot, this dot, this dot, and this dot. Well, that would be discrete domain because they're not connected. They're just showing you individual dots. So it would only be whatever that dot is right there. It looks like 1, 1. This one, 3, 3, 5, 5, and 7, 7. So the discrete domain would just be 1, 3, 5, and 7. The line is not connected, so we are not including the numbers in between. A good example of a discrete function would be something like movie tickets. Okay, if you buy one movie ticket, let's say it cost you $5. And if you buy 2 movie tickets, let's say this is 5, 10, 15, 20, and so on. So 2 movie tickets, $10. 3 movie tickets, $15. 4 movie tickets, $20, and so on. There's no such thing as buying 2.5 movie tickets, so therefore we're not going to include, which would be right there, up to 2.5 and whatever that is, $12.50. It doesn't make any sense. So that's why we do not connect those dots. It's just individual tickets, and you can't buy like 2.5 or 3.5 tickets. It's not included. So that would be an example of why something would be discrete. Because in the real world, it doesn't make sense to have 2.5 tickets, for example. Continuous, then, is obviously the opposite. So continuous function just means that you may, again, still have these same dots, but they are connected. And what that's saying is it's not just including the dots, it's including everything else in between. So anything that could be continuous. So for example, like how many miles you could go, and let's see, if we did miles you could go and gas in your tank. Well, when you have a lot of gas, you have a lot of miles you could go. So let's say, okay, sorry, I tried to draw it a little bit better. So let's say that this on this side is the number of gallons that you have in your tank, so how much gas you have, and then this is your miles driven. So at 1 mile, you have your gas tank is full, and maybe then the next one is 100 miles, then it's a little less full, and 200 miles, a little less full, and 300 miles, a little less, and so on, 400 miles, until eventually you're going to be empty. So this would be continuous because you can drive, like this first one, whatever I said, what was that, 100 miles or 10 miles or whatever it was. So could I drive 15 miles? Well, of course. Could I drive 150 miles? Yes. Could I drive 227 miles? Yes. I could figure out exactly in between there what that was. It's not like we're just driving 100 miles, or we're just driving 200, or we're just driving 300. We could easily drive those miles in between there. So that's why on the continuous one, it says it consists of all the numbers, even including decimals, because you can go like 110.5 miles. That makes sense. And I don't know how many people would keep track of that, but that's at least possible. Whereas up here with the movie tickets, it's impossible to buy 2.5 movie tickets.